Sellers. Welcome to CISS226, and I'm not going to cover things about how the class is set up and what the schedule is and all that. All that is available in Canvas. So this being a blended class, I'm going to take advantage of the lecture time I have to just cover the material, and other stuff is posted to Canvas, so please be sure to read it. So I'd like to today go over how a Java program is set up, what happens in the process of compiling and running a Java program, and so on. I have this very expertly drawn chart that sort of shows the flow here. We have our source code, which is a .java file. It ends in a .java extension. We take that and run it through a process known as compiling it. And that produces byte code, which is in a .class file. And that actually is input to the Java virtual machine, and that's how we run the program. Everything in Java is contained in a class, and for the most part, it's tough to make very general statements, but most of the stuff we're looking at that we'll look at in Java is going to be contained in a class. And typically there is, at least starting out, there'll be one class per Java file, .java file, and that will compile to a .class file. Now this .class file contains what is called byte code, and that's one thing that makes Java platform independent. Because as long as you have a Java virtual machine for your platform, whether it be Windows or Linux or Mac or whatever, you can run a Java program that's been compiled into byte code. So the byte code is platform independent. All you need is a compiler for your particular system and a JVM for your particular system, and you can run the byte code on any machine. That's the theory anyhow. Now, in practice, I'm sure there are some gotchas, but that's the basic theory for it. And that's one of the chief advantages, at least in the past, of Java, was that it was platform independent. All right, we're going to look at the typical starting out program in Java, the Hello World program. And I have it stored in this folder, and this is the source code. So it's titled hello world.java. And the names of the files are important here. With Java, there are conventions that we follow, and it's best to follow them. If we look at this .java file, I'm going to bring it up and edit it in Notepad++. And this is a file that I downloaded from somewhere, but it's a hello world. First of all, at the very beginning, we have a /* and ending with a // we have a block of comments. This is the same for those of you that have done C#. It designates a block of comments. All right, the actual code starts at line 20, where we have public class hello world. Now, notice that the class hello world, the name of the class, which is here, hello world, matches the name of the file exactly. Hello world.java contains the class hello world. Notice by convention, the first letter of every word is capitalized. All right, please pay attention to these conventions. It really helps you keep things straight. So if you have a customer class, make it customer with a capital C. If you have a graduate student class, make the class name graduate student with a capital G and a capital S, and put it in a file that is called graduatestudent.java and so forth. And put one class per .java file. All right, so please follow those conventions. Some of them are rules, and you'll get a compile error if you don't follow them. Others are just by convention. All right, this is very similar to the code that you see in C#, where the braces are used to sort of wrap around things. So in this case, everything between this brace and this brace is part of the public class hello world. This designates it's a class. This designates that other classes can refer to it and call stuff in this class. It would, in this case, since this is the only class in our application, it would make no sense to make this private because you wouldn't be able to run it because no one would be able to access it. So we make it public class hello world. For the most part, most of the classes we make are going to be public. All right. So for the first good part of the semester, just assume that they're going to be public. One class is your main class within your application. All right. And what makes it the main class is it's the class that actually runs and starts and accesses the other classes that you need. All right. And by the main class, I mean that it has a main method. All right. Method, function are pretty much the same thing. Now, notice this main method, public static void main. Then we have a list of arguments, and we have our braces, and everything between those braces is our code. All right. Now I've sort of souped up this code a little bit by putting in a random generator that picks a list, picks from this array one of these four names and displays it. Right? Getting back to this, the public static main void, all of your main methods are going to look like this. Public means that it can be accessed outside of this class, which is necessary if you're going to run this program. Static means it's associated with the class and not the object. It's not really important that you understand that now, except to say that you do need to make it static. Void simply means that this function does not return anything. Then we have the name of the function, and then we have a string array of arguments that we can access. All right. This is going to be the declaration for all your main methods. So every program you write is going to have a main method, and it's going to look exactly like that. Right? These arguments you can actually pass to the class and pass to the main method from the command line. Right? So what do we have in this class? This declares an array. And arrays in Java are like arrays in C#. They are a list of values, a list of a particular kind of values. In this case, a list of strings. And they're declared this way with the braces. And then in this case, the strings are in quotes with a comma in between them. So this has four values in it. And the values are numbered 0 through 3. So Mike is names sub 0, Joe is names sub 1, Jerry is names sub 2, and Joyce is named sub 3. The next line generates a random number, generates an integer that we're going to call random. Again, very similar syntax that you get in C#. And we're going to call a math random function. And what that does is that generates a number between 0 and 1. Or I should say 0 between 0 and 0.9 repeating. All right. Now, when we're going to multiply that by 4, we're going to get a number that could start at 0 and goes all the way to almost 4. All right. Math random gives you a number that starts at 0 and goes to almost 1. So if we multiply it by 4, we're going to get a number that starts at 0 and goes to almost 4. In other words, 0, 1, 2, and 3, because we are converting that or casting that value to an integer. So this is giving us an integer between 0 and 3, which of course corresponds to numbers 0, 1, 0, 1, 2, and 3. I then am going to output, and I'm going to use the system class to output, and I'm going to print ln. I'm going to print a line, and it's going to print out this string, hello, comma, and then it's going to concatenate onto that string the value of the array that we have chosen based on our random number. Now, before we leave this code, and I do have an explanation of this that I pulled from another place that we'll look at in a second, you could actually do better than multiply by 4. There's a way to get the length of an array. And if you use that in there, all you have to do is add an element to the array, and you would not have to change this line of code again. Let's look at that. We look at Java arrays. Talks about creating them. Here we've created a list of cars, a list of integers. We can access things that way, change things that way, and the array length would be cars.length. So in this case, if we were to say math.random times names.length, then we would make this code a little more maintainable, because if we were to change the list to add or subtract elements, we would not have to change this line of code. Making your code maintainable is a big goal of what you do as a software developer. All right, and most of the time when we talk about practices of what a good practice is and so forth, is because it makes the code more maintainable. All right, so let's go and actually run this. Now, we're going to start out in this class simply using text editors. I'm using Notepad++. At some point in the semester, I'll probably switch to Visual Studio Code. All right, and we're going to do things from the command line. And if you're not familiar with the command line, don't worry. It's pretty simple to get to. I'll show you how to get to it in Windows. On a Mac, you simply go to the terminal. All right, you create a terminal window, and you navigate pretty much the same way. If you've had the operating system class, you probably have done some work from the command line. So I'm going to open up the command line. I get this prompt. It starts me in my directory. I want to go to the desktop. If I do an ls, it tells me that that's not a command because I am thinking Unix. If I do a dir, it shows me a list of all the things that are in that directory. My code I put in a folder called Java in the desktop. So I'm starting off in Zellers. I can do cd desktop /Java. And I end up in the right folder. Go to the screen here. CLS. I'll probably do that a lot because, again, I am a Mac user and Mac runs a variant of Linux. Its operating system is based on Unix, and I probably remember the Unix command better than the Windows commands. So I'll do a dir, and it shows me the contents of this folder, the hello world, .java. Now, from the command line in Windows is not case sensitive. Notice I typed in cd desktop Java, and I used the lowercase d. Everything within Java is case sensitive. So for example, here where I have public static void, if I had a capital S for static, it would not compile and it would give me an error. Now, there's information about how to install Java. This is how you know that you have installed it correctly. You need to install the JDK, the Java Development Kit, and not just the Java Runtime Engine, which is the JRE. So I can tell if I've installed it correctly if I can compile it. And how do you compile the Java code? You type in Java C along with the class that you want to compile. Hello world.java. Right? Now, if the hello world used other classes, it would compile those as well. It did not display anything. That means that we did not get an error. Okay? Sometimes, just for shorthand, I'll type in Java C star.java. That will compile all of the Java code that's in that folder. And again, no errors. If we look in that folder, we notice that now we have the class file that ends in a .class, which, if you remember, we talked about that before. You take the source code, which is a .java file, compile it, and get the byte code. The byte code is not machine readable. So if we wanted to try displaying or editing that, we went in to try to open this up in Notepad++. We really can't read it, all right, because this is compiled into byte code. I could take this, however, provided I had the correct version, and run this on my Mac, all right? I would take the .class file and move that over, and I would be able to run it, even though it was created and compiled on a Windows machine. That might not be as big a deal now as it has been in the past, but in the past that was really a really big deal and a selling point for Java. How do I run it? By typing in Java and then the name of the class. That's my initial class, my main class. In other words, the class that has a main method. I run it, and there it goes. It generated the random name of Joyce, and it goes, hello, Joyce. It generated subscript 3. Now, one thing you'll see me do a lot is if I went in and changed some of the code, let's see. I think I closed this out of Notepad++. If I wanted to change Joe to Joseph, for example, all right, I have to recompile it, otherwise it's not going to work. Let's change all of these. All right. If I just save it and run it again, it doesn't pick up the new names. I have to save it and recompile it. One thing I wish you could see, but you can in this environment, is I can get back to old commands in the command line simply by using the up arrow. So if I hit the up arrow once, it shows me the last command I ran. Again, shows me the second to last. So usually what I do is I'll have my class open in my editor. I'll make the changes. I'll save it. I'll hit the arrow a couple times to recompile it. And then I'll hit the arrow a couple times to run it. Whoops. Confuse myself there. There you go. Hello, Gerald. So the changes have been reflected. What if something goes wrong? What if you make an error? Well, some of the main errors that you'll run into is you'll run into capitalization errors, right? So if you made this, for example, public static void with the capital S, if I go and try to compile it, it's going to give me an error. All right, now the errors that it gives you are not always 100% clear, but it gives you an idea of where the error is. For example, this tells me that it's in the hello world.java class at line 22. It's expecting an identifier, which, what's an identifier mean? But it puts the cursor, puts a little caret rather, around where the error is. So the error is around public static. So around this area is where to look on line 22. So we look here, and hopefully by then you'd realize that, oh, I have static wrong. It takes a little while to develop those skills. And I encourage you to try when you're debugging to figure out the errors by yourself. Of course, if you get stuck, if you've spent too much time trying to figure it out and you get stuck with an error, just ask a question. Email me the code and ask a question. Now that I've corrected that, I can compile it and it runs. Another common mistake is if you'd have things not match up. Like if I get rid of that brace. If I get rid of that brace and I try to compile it, it'll tell me it reached end of files while parsing. Now, again, those words are a little cryptic. In a nutshell, what it means is it made it to the end of the file and it didn't find something it was looking for. All right. And what it was looking for is the final brace. This brace that matches up with this, but it's not able to find a brace that matches up with that. So again, the solution would be to put that back in. Likewise, if you have an extra brace, you'll also get an error. See what wording it gives you for this error. It says class interface or enum expected. What that's telling you is that this class is finished because this finishes that class, and therefore it's expecting something else to come after it in the file. And in our case, we're going to stick to pretty much one class per file, so it's expecting more, but we don't have anything more to give it. All right, let's look at the explanation that they give you online for the Hello World app. And it shows you most of the same things that I showed you, the comments, class definition, and so on. So take a look at this, and that will give you a little bit different view than what I gave you. Your main job this week is to make sure that you've gotten Java installed correctly and running. So the way you can do that would be to follow the instructions listed here. You can Google and find examples of pages that describe to you how that you can install Java and so on. The one thing I will say, and to back up a second, remember to install the JDK and not just the JRE. The one mistake that people make, especially in Windows, is setting the path variable. All right. So take a look at that and make sure that you have done that correctly. And again, either Google it or you can email me and we can discuss, if you're having difficulties, how to set that path variable, because it needs to know, the command line needs to know where to find those Java compile commands at. I think that's all I had. make sure you, early on in the week, try to get Java installed, and make sure you can compile the Java world example. If you get an error compiling it, the two main things that I've found is students did not install the right JDK. They installed the JRE. That's one problem many students have. The other problem that students have is not saying the path variable correctly. Usually is one of those two problems that keeps people from able to run it. How would you know if you can't run it? You know it because if you typed in Java C and the name of your program to compile, it would not give you, it would not compile. It would tell you that the Java C command is unrecognized. Okay, that's all I had. I wish you a great semester, and we'll talk to you later, and we'll see you, or at least some of you, next week. Take care.